Problem 5 is identical to problem 4, but instead of analyzing how the government spending multiplier changes as short and aggregate supply gets increasingly inelastic, problem 5 analyzes how the tax cut multiplier is affected by the slope of short and aggregate supply getting closer and closer and closer to zero. The values in Part A, potential output $15.41 trillion, the intercept of aggregate demand, the intercept of short and aggregate supply, and the slope of short and aggregate supply have all been entered into the spreadsheet we used in problem 4. So the initial intercept is 22.6, the MPC is 0.75, the MPM is 0.25. Because the MPC subtracted from 1 equals the MPS, and the MPS plus the MPM is the slope of aggregate demand. The slope of aggregate demand is 0.5, so we're going to copy that into Cengage now. We're going to use the graph in Excel to determine the initial equilibrium. So the initial equilibrium looks like the initial price level is 15.87. The initial level of GDP is $13.460 trillion. The output gap is the difference between real GDP and potential. So this is real GDP and this is potential. We're going to take that difference in Excel, maybe down here, and we get negative $1.95 trillion. So the economy is in a recessionary gap. This is short and aggregate supply, and it's more inelastic than is aggregate demand, and this is longer aggregate supply. Price level, or PL, in thousands of dollars, real GDP, or Y, in trillions of dollars. So the economy is in a recessionary gap. Suppose economists at the CEA estimate that a $3.9 trillion cut in taxes will close this gap up here. So the hint in getting the new intercept of aggregate demand is to take the old intercept, 22.6, initial intercept, and then to add to it the MPC, which is 0.75, times the value of the tax cut. So we're going to copy this into Excel down here, and we get 25.525. To double check that is the case, we're going to take the tax cut here, 3.9, and we're going to put it up here. And the tax cut of $3.9 trillion is enough to close this gap. So we need a huge tax cut to close this gap because short aggregate supply is relatively inelastic. And you can see that the intercept, the new intercept of aggregate demand is in fact 25.25. The slope is still 0.500. That didn't change because the MPC and the MPM are held constant. We're going to get the final equilibrium from the graph. Real GDP is equal to potential, 15.41, and the price level is $17.820 thousand. The final equilibrium is $15.41 trillion. The gap is zero because aggregate demand and final aggregate demand, short aggregate supply, and long run aggregate supply all intersect at one single point. The multiplier is the increase in GDP. Final GDP is $15.41 trillion. GDP was 13.46. So we take the increase in GDP and divide that by the size of the tax cut, which is $3.9 trillion. So I have the tax cut in absolute value. I have the increase in GDP, and I take that and copy it into Excel to compute it. So again, the increase in GDP is that difference, and this is the tax cut, which is 0.5. In part D, we need to calculate the growth rate and the inflation rate for scenario A. Also, we need to choose short aggregate supply is relatively more inelastic than aggregate demand because it was steeper than aggregate demand. I've copied the initial values of real GDP and the price level, 13.46 and 15.87, into Excel here. So this is the initial equilibrium. I've done the same thing with the final equilibrium, 15.41 and 17.82. So this is the final equilibrium. The economic growth rate is the percent change in GDP, which is calculated by taking what GDP is, subtracting off what GDP was, then divided by GDP was, and multiplying by 100 to convert it to a percentage. The economic growth rate to 3 decimal places is 14.487. The inflation rate is the percent change in the price level. So all we have to do is pull this down, double click to make sure we calculated everything correctly. It's what the price level is minus what the price level was divided by what the price level was times 100 to turn it into a percentage. So I'm going to copy these into Cengage Now, Part D, one at a time. So I have an economic growth rate in scenario A of 14.487 and an inflation rate of 12.287%. In Part B of the problem, short and aggregate supply is different. It has a bigger intercept and it is more elastic than what short and aggregate supply was in Part A. In Part A, the slope was 1. In Part B, the slope is 0.25. I've copied all these numbers into the Excel spreadsheet we've been using in problem 4 and 5. So you can see down here in this diagram that short aggregate supply has a larger intercept than it had in Part A, and it is much flatter or more elastic than what it was in Part A. The equilibrium price level is 15.870. Real GDP is 13.460. The gap, the output gap, is the difference in what GDP is and potential. Potential GDP is $15.41 trillion. I'm going to copy this into Excel to compute the number. So the output gap, the difference between what real GDP is, 13.46, and potential is a negative 1.95. This diagram is identical to the one in Excel. Short aggregate supply is relatively more elastic than aggregate demand. And this right here is long-run aggregate supply. And you can see graphically that real GDP is less than potential. This axis is PLR, the price level, in thousands of dollars. This axis is labeled Y, real GDP, in trillions of dollars. The economy is in a recessionary gap, and economists at the CEA estimate that a $1.95 trillion tax cut will close the output gap. To get the final aggregate demand intercept, the aggregate demand curve that will go through this point here, we copy the initial intercept into this blank down here. And then we add to that the MPC, which is 0.75, times the size of the tax cut. And that gives us the new intercept. To compute it, I'm going to copy it into Excel. And it looks like the new intercept in 3 decimal places is 24.063. To verify that the new intercept is 24.063, I'll copy this tax cut into the simulation. Make it negative first, because it's a tax cut. And the gap should be closed down here when I hit enter. So when I hit enter, this dot will end up over here, because aggregate demand is going to shift due to the tax cut. And it does. And you can see here that the intercept at 3 decimal places is in fact 24.063. The slope is still 0.50. I'm going to use the graph in Excel to get the final equilibrium. Real GDP is potential, 15.41. The price level is 16.35750. But we only need that to 3 decimal places. Because that's a 5, we got to make that an 8. And real GDP was equal to the potential output level. The gap is 0 for that reason. The tax cut multiplier is the ratio of the increase in GDP so this is the difference in GDP, 15.41 minus 13.46. This is what GDP was before the tax cut. This is what it is after the tax cut. We're going to divide that by the size of the tax cut. And to do the calculation, I'm going to copy this into Excel. And I get 1 to 3 decimal places. In part D, we need to get the growth rate and the inflation rate for scenario B. We also need to choose short and aggregate supply is relatively more elastic than aggregate demand, because in scenario B, short and aggregate supply is flatter or has smaller slope than does aggregate demand. The initial equilibrium is right here. I've copied these values into Excel. These numbers represent the initial equilibrium. I've also copied the values of the final equilibrium into Excel. These values represent the final equilibrium. The economic growth rate for scenario B is what GDP is minus what it was divided by what it was times 100. The inflation rate is equal to what the price level is minus what it was divided by what it was times 100. So the economic growth rate is the same as it was in scenario A, but the inflation rate has dropped to 3.075. So as the short and aggregate supply curve gets more elastic, the inflation rate is coming down. In scenario C, the short and aggregate supply curve is now perfectly elastic, with an intercept of 15.87 and a slope of 0. These numbers have all been copied into the spreadsheet that we've been using for problems 4 and 5. So in the spreadsheet, I've just changed the intercept to 15.87 and the slope to 0, and you can see that the short and aggregate supply curve is perfectly elastic. The equilibrium here is indicating that real GDP is 13.46 and the price level is 15.87, the value of short and aggregate supplies intercept. I'm going to copy the 13.46 into Cengage now. The slope of aggregate demand is still 0.5 because the MPC is 0.75, which implies an MPS of 0.25. 0.25 plus 0.25 is 0.5. So initial GDP is 15.460. The equilibrium price level is equal to the intercept of short and aggregate supply. The gap is the difference between what GDP currently is minus potential output. So I'm going to copy this into Excel to compute it. And it's a negative $1.95 trillion. So this is the same graph that you saw in Excel. Aggregate demand is here. Perfectly elastic short and aggregate supply is here. The two intersect to the left of long run aggregate supply. This is price level, or PL, in thousands of dollars. This is real GDP, Y, in trillions of dollars. The economy is in a recessionary gap. Economists at the CA estimate that the $1.3 trillion tax cut will close this gap. To compute the new aggregate demand intercept, we take the tax cut of $1.3 trillion, multiply it by the MPC of 0.75, and we're going to add that product to the initial aggregate demand intercept. So we have the initial aggregate demand intercept plus 0.75 times the tax cut. And I'm going to copy this into Excel to compute that value. So the new intercept is 23.575. To verify that, we're going to insert $1.3 trillion into the Excel simulation. We've got to make it negative because it is a tax cut. And when I hit enter, aggregate demand will shift from here to here. And it does. Right, so the tax cut closes the gap. And you can see that the aggregate demand intercept is indeed 23.575. The slope is still 0.5 because the MPC and the MPM have not changed. We're holding them constant. The final equilibrium values are going to be copied from the Excel diagram. Aggregate demand and short and aggregate supply intersect at long run aggregate supply, so the new equilibrium level of GDP is 15.41, which equals potential GDP. The price level is equal to the initial price level because short and aggregate supply is perfectly elastic, and that value is short and aggregate supply, intercept. And the gap is 0. The multiplier is the increase in GDP resulting from the tax cut. So the increase in GDP resulting from the tax cut is the difference between $15.41 trillion and $13.46 trillion. We're going to divide that by the tax cut of $1.3 trillion. To compute that value, we're going to copy this into Excel. So when we divide the increase in GDP by the tax cut, we get 1.5. This diagram is identical to the one in Excel, but it also includes the initial aggregate demand. So we have initial aggregate demand, final aggregate demand that results from the tax cut, and it intersects long-run aggregate supply and short-run aggregate supply. In Part D, we have to calculate the economic growth rate and inflation rate for scenario C. We also have to choose short-run aggregate supply is perfectly elastic. Initially, real GDP was 13.460 and the price level was $15.870,000. These values are copied into Excel right here. So these numbers represent the initial equilibrium. The equilibrium following the tax cut is right here. Final GDP was $15.41 trillion. Final price level was $15.87,000. These numbers represent the final equilibrium. The economic growth rate is the percent change in GDP, which is what GDP is minus what GDP was divided by what GDP was times 100. And the inflation rate, which is what the price level is minus what the price level was divided by what the price level was times 100. So the inflation rate has dropped to 0%. The economic growth rate is still 14.87%. So again, as the short aggregate supply curve gets relatively more elastic, the inflation rate goes to 0. If the short aggregate supply curve is relatively more inelastic than aggregate demand, the multiplier is less than 1. And fiscal policy is very inflationary because the inflation rate was 12.387 after the cut in taxes. The multiplier was much bigger when short aggregate supply was relatively more elastic than aggregate demand. In addition, fiscal policy is not as inflationary when short aggregate supply is relatively more elastic than aggregate demand. The multiplier reaches its maximum level of 1.5 when short aggregate supply is perfectly elastic. In this situation, fiscal policy is not inflationary. The tax cut multiplier increased in value as the slope of short aggregate supply declined to 0. The inflation that resulted from the cut in taxes is higher as short aggregate supply got relatively more inelastic. The tax cut multiplier in scenario C equals the tax cut multiplier in the aggregate expenditure model because the price level is being held constant as the tax cut is analyzed. Now I'm going to check my work and we should have everything correct. And it looks like we got everything correct. Initially I inserted 3.075 here. I needed to change it to 3.072 because when I calculated the inflation rate for scenario B, I got 3.075. That is wrong. And the reason why it's wrong, according to Cengage now, is because the price level initially wasn't 16.358. In scenario B, the price level is actually 16.3575. So if I use 4-digit decimal accuracy on the price level, the inflation rate drops to 3.072, which is why I changed it. So the moral of that story is to use as many decimal places as possible on intermediate calculations.